All right, so FRQ number 2 is a non-calculator question. So we have a function f of x, or f, and then we have the graph of its derivative. So everywhere at each point gives the derivative at that point, or gives the slope at that point. All right, so for 2a, we want to find the average rate of change of f over the interval from -1 to 4. And let's just start there. So the average rate of change from -1 to 4. Now make sure you're looking at f. So -1 is here, 4 is here, so it's basically the slope of that line. We technically could count, but you're probably going to need to show some work. And so the work you would want to show for average rate of change is going to be f of 4 minus f of -1 over 4 minus -1, right? You would probably get a point just for writing that. And then if you go back on the graph and find those values, you would write them on the numerator. So f of 4 is going to be 1, and f of -1 is going to be -2. All right, and then I can go ahead and make a 5 down there. So that is going to be, when I change it to plus the positive, that is going to be 3/5. And we're not done with A, because there is another question embedded in there. So the other question is, for how many values of x in that same interval does the instantaneous rate of change equal the average rate of change? So this f prime of x, that is the same as the instantaneous rate of change. So we want to know how many times between -1 and 4 that the graph is equal to 3/5. So I would say 3/5 is about right there. And so if I just drew a line, it looks like the instantaneous rate of change is equal to 3/5 twice. So you could say something like, there are 2 values. Maybe better, since it would be better if we said 2 x values in which the average, and for rate of change, it's going to be fine if you do ROC, equals the instantaneous rate of change on the interval from -1 to 4. And of course you could use this, or that is the notation they used. No, you could use the notation that they use also. It doesn't matter. Both of them are fine. It's just a little quicker to do interval notation. Okay, so let's look at number 2, or letter B. We're going to write an equation for the line tangent to f at x equals 1. Okay, so this is kind of weird because we need the slope of f at 1. And if we were just looking at the graph, we could guess, we could see that, yeah, it's negative. We can make an estimate. But this is the graph of the slopes. So I erased average or instantaneous rate of change. You can leave that, but it's also the graph of the slopes. So when x is 1, this graph is down here at -2. So that means the slope when x is 1 is -2. That's the same thing as m. All right, the other thing we need for the tangent line is the point of tangency. So with that one, we would go to f. We would want to find f of 1. f of 1 is 2. So you could write it that way, or you could write it as an ordered pair where this is x1, that's y1. And then we could just write our tangent line. So y minus the y part of the point equals the slope, and then is multiplied by x minus the x part of the point. That is a pretty advanced question right there. There was nothing like crazy hard. You just had to be creative about finding your information. All right, then for C. So we have two limits. Now, these are both derivatives in disguise. All right, so this one is asking you to find f prime of 2, and this one is asking you, this one is asking you to find f prime of 2. This one is asking you to find f prime of 3. So I'm going to write that down. You would want to write that down, that the limit as x approaches 2 of f of x minus f of 2 over x minus 2 means f prime of 2. And you could write the same thing about 3. All right, so let's see what happens at f prime of 2. All right, f prime of 2 looks like it's going to be 1. And then f prime of 3, if you look at it, there's an open circle at 3, there's an open circle at 3. So that limit does not exist, or that derivative does not exist. So that must mean the function is not differentiable there. So let's look and see what's going on the function when x is 3. So you can see when x is 3, we have this sharp turn. That's going to make this function not differentiable there. That's why you have those two open circles on the derivative. So I think it asks us to tell why. So you would say the graph of f has a sharp turn at x equals 3. Now it's important that you're very specific, that you don't just say the graph. It has to be the graph of f. All right, so let's look at D. So we're going to have a new function g that is defined as e to the x times f of x. And we want to find g prime of 0. So this is another one like what we did earlier. So what we would want to do is go ahead and find g prime. So we would leave the first one alone, multiply by the derivative of the second, then leave the second one alone, and multiply by the derivative of the first, which happens to also just be e to the x. Then you would go back and put 0 in for all of your x's. So e to the 0 is 1. F prime of 0, let's go to the f prime graph. F prime of 0 is 1. All right, f of 0, we're going to go to the f graph. F of 0 looks like it's 3. We're going to say it's 3. And e to the 0 is 1. So looks like that is just going to be 4. And that's how you do the second free response question.